Hello everyone, I'm Dr. Jagadha, Associate Professor in the Department of Mathematics. Today we are going to discuss about eigenvectors for repeated eigenvalues. This lecture completely we are going to discuss about definition of eigenvalue and eigenvector. Then eigenvalues, how to identify distinct and repeated eigenvalues, and eigenvectors for the eigenvectors for repeated eigenvalues, how to find also. While solving a problem, these three definitions, identifying distinct and repeated eigenvalues, we will find eigenvectors, which will cover while solving the problems. So definition of eigenvalue. So let capital A equal to Aij. So the capital A, it's nothing but our given matrix. I stands for row, J stands for column, N by N, it's nothing but square matrix, that is number of rows and number of columns are equal, we will call it as square matrix. A non-zero vector, capital X. That means the capital X, it should not be a zero vector. So you can see it is a zero vector, but capital X, it should not be a zero vector, then it is non-zero vector. So this is non-zero vector. Is said to be a characteristic vector of capital A, that is our given matrix. Then, if there exists a scalar lambda such that Ax equal to lambda x. If Ax equal to lambda x, where x is not equal to 0, means x is not a zero vector, x is non-zero vector. Then a capital X is the eigenvector, or we will call it as characteristic vector of A, corresponding to the eigenvalue of given matrix A. So we have to, this A is nothing but given matrix, lambda is playing the role eigenvalue, X is playing the role eigenvector. Compulsory the condition capital X, eigenvector is a non-zero vector. We are going to solve a problem. Find eigenvalues and eigenvectors for the following matrix. So capital A, it is given. The problem is 3 by 3 matrix. 3 rows are there, 3 columns are there. It's a 3 by 3 matrix. It is a square matrix, because in the definition itself it is given n by n matrix. So the problem, it should satisfy all the conditions. So 3 by 3 square matrix. If lambda is the eigenvalue of our given matrix, that is our given problem, and capital X is the corresponding eigenvector, then by the definition A minus lambda I of x equal to 0. So A, it is written the given matrix, lambda is written as it is, I, it's a unit matrix, that is we have taken 3 by 3 because the matrices are same order, then only it is possible to subtract. That is the reason here this unit matrix also, it is taken as I3. It is taken I3, not I2. Because this is 3 by 3, we have to take unit matrix also I3. Then X capital X, x1, x2, x3. It's a 3 by 3 matrix. That's what we stopped up to x3 equal to 0, 0, 0. Yes. Now, in this step, we wrote it the first, that is a given matrix A as it is, minus this lambda we have taken inside. That is lambda into 1, lambda, lambda into 1, lambda, lambda into 1, lambda. That is this 1, 1, 1. These elements are lying in the principal diagonal. So lambda is multiplied. So completely the elements which lie on the principal diagonal, it has become lambda, lambda, lambda. Remaining, we know it 0 into anything, 0. So others, all it is zeros. This as it is, this is also written as it is. Yes. Now, this we have to do these both matrices subtraction, where this we know it 0 is playing the role additive identity. So minus 2, this minus 2, 2, and here this minus 1, 2, and minus 1. These elements we have to write as it is, because minus 2, minus 0, same as it is will come, because 0 is playing the role of additive identity, where the changes will come. 6 minus lambda here, 3 minus lambda, 3 minus lambda. This written as it is, this is also written as it is. Yes. Now, characteristic equation of capital A is determinant A minus lambda I equal to 0. We are going to expand by R1. That is, this matrix is there. This matrix we are going to find determinant, and in the determinant we are going to expand. Either R1 way we can do, otherwise C1 way also, any way we can do. Here we are doing R1. This green color, the rectangle 1 represents, there is R1. So the determinant, so you can see it 6 minus lambda, this 3 minus lambda into 3 minus lambda, that's what 3 minus lambda the whole square, minus, this minus is formula minus, minus into minus 1 plus 1, already formula minus is there, minus 1. That is, here we are doing the cross multiplication. 3 minus lambda into 3 minus lambda, it's nothing but 3 minus lambda the whole square minus of minus 1 into minus 1, it is becoming minus 1. Next, this position is nothing but negative position. So minus of minus 2, that is what it is, plus 2. Next, this determinant, the minus 2 is there. This element, it is there, this position, the corresponding column, row we will neglect. The balance one we will do the cross multiplication. That is minus 2 into 3 minus lambda. Yes. Minus, that is formula minus. 2 into minus 2, minus 2. Formula 1 minus is there. It is becoming plus 2. So very careful we have to be. This position symbol is plus. This position symbol is minus. That's what minus of minus, it is written here, plus. Here is plus. You can see it here. The position is plus 2. This, here, this position, the value is 2. This particular row, particular column, we will neglect it. So the balance we will do the cross multiplication. So minus 2, minus 1, plus 2, minus, that is, this is formula minus. 2 into 3 minus lambda equal to 0. So that is written once again. So we can see the simplification part. 6 minus lambda as it is. This is a minus b the whole square. Simple formula. that is we wrote it here, that is lambda square minus 6 lambda, actually plus 9 is there, here minus 1 joining, it is becoming plus 8 plus 2, this is here minus 2 minus 6 minus lambda plus 2, here the simplifications we got it, here you can see here this is becoming the 2 lambda and minus 6, this is plus 2, it is becoming minus 4. You can see here this plus 2 as it is written. Next 2 minus 6, 2 minus 6 minus 4, minus 2 minus lambda, it is becoming 2 lambda. This as it is written, lambda, this also as it is. Here if you are seeing this term and this term, both are common, so we wrote it. If it is written common coming outside, here the balance is plus 2, here the balance is plus 2, it is becoming plus 4. Next, 6 taking, we are completely multiplying, that is 6 lambda square minus 36 lambda, next 48, next minus lambda cube plus 6 lambda square minus 8 lambda. Now this 4 we are taking, 4 into 2 lambda, 8 lambda minus 16 equal to 0. So minus this part it has come here. Then 6 lambda square, 6 lambda square, it is becoming 12 lambda square minus 36 lambda. This if you are seeing 48 is there, minus 16 is there, it is becoming plus 32. Next here minus lambda cube plus 12 lambda square minus 36 lambda plus 32 equal to 0. Just we are changing the sign. Lambda cube, that is wherever the negative, it is becoming positive. So lambda cube minus 12 lambda square plus 36 lambda minus 32 equal to 0. It is written. So we can see here this lambda cube, the coefficient, that is the value is 1. For lambda square minus 12, 36 lambda 36 minus 32. That is, we got one cubic polynomial in terms of lambda. We are going to solve the values we wanted. Lambda, 3 values we wanted. That is, because it is a cubic polynomial, 3 values must. Lambda, that is 3 eigenvalues we are going to get. Here to solve, we are using the synthetic division. That method we are using. So we wrote it 1 minus 12, or we wrote it. So you can see here, it is a default. Here we have to take here 0. To satisfy this, that is, we have to first put 1, minus 1, 2, minus 2 like that. So if you are keeping 2, it satisfies. Then 1, 0, 1 plus 0, we are getting 1. 1 into 2, we are getting 2. Minus 2, minus 12 plus 2, we are getting minus 10. Minus 10 into 2, we are getting minus 20. Next 36 minus 20, we are getting 16. So 16 into 2, we are getting 32. So minus 32 plus 32, we are getting 0. Yes, this 2 if you are taking, it satisfies. Next, so this is a cubic polynomial in terms of lambda. From cubic polynomial 2, it is reduced to quadratic. That is, this is lambda square minus 10 lambda plus 16. This easy way, factorization method, we can solve. That is lambda square. This minus 10 lambda, that is splitted into minus 2 lambda minus 8 lambda plus 16. So here common, it has taken lambda outside. So the balance is lambda minus 2 is written. In these two, minus 8 is common. The balance lambda minus 2. Here, both the common is lambda minus 2. So lambda minus 8 it has become. Now, you can see this lambda minus 2. This part is written here. So, here lambda minus 2. This already we solved it. That is written here. So, lambda minus 2 equal to 0. Lambda equal to 2. Next also lambda minus 2 equal to 0. Lambda equal to 2. Lambda minus 8 equal to 0. Lambda equal to 8. So, lambda 3 values 2, 2, 8. So, 2, 2, it is repeated. That is only our topic. So, the eigenvalues are repeated. Distinct means this is 2, 1, 8. They will be different, distinct eigenvalues. But now this topic is repeated eigenvalues, which 2 is repeated and 8. The repeated one is 2. 3 compulsory, 2 is repeated. So the eigenvalues are lambda equal to 2, 2, 8. So the eigenvector corresponding to eigenvalue, that is lambda equal to 8. So A minus lambda x equal to 0. This meaning, the non-zero solution xi of homogeneous system is the eigenvector corresponding to the eigenvalue lambda of the given matrix A. That is the meaning of this mathematical reference. Now, A is, this is already the previous slides it has come that we have taken. Now, lambda equal to 8. So, wherever lambda is there, we are going to substitute 8. So, the changes will be there here only. 6 minus 8. 3 minus lambda, that is minus 8 minus 5. 3 minus 8. So, you can see here, yes, this animations which helps us to understand more. That is minus 2, minus 5, minus 5. These elements which lie on the principal diagonal, how we got it? That is lambda equal to 8 is substituted here and we got it. So this is the thing we got it. Now this we have to do the multiplication. Multiplication part. So here minus 2, 2. The first row of the first matrix we will take, finish the column. The work to be done. That is minus 2 into x1. Minus 2x1. Minus 2 into the second element. Minus 2x2. 2 into x3. So first equation is completed. The first row, the job is over. We will move to the second row. So the first matrix we will concentrate on row basis. So minus 2 into x1. Minus 2x1. Minus 5 into x2. Yes. Minus 1 into x3. Yes. 2 into x1. 2x1. Minus 1 into minus x2. Yes. Minus 5x3 equal to 0. We got the 3 equations. With the help of these 3 equations, our aim is to find out the value of x1, x2, x3. That is, here we are taking solving equations 1 and 2. It is not strictly we have to take always 1 and 2. Any 2 equations we can take. So the first 2 equations taken. This is the very simplest method. We can adopt this method to find the solution of these equations. What is done? Here, the coefficient minus 2 is written. Next, 2 is written. Next, minus 2 is written. Next, minus 2 is written. Next, you can see, here is starting, minus 5. Next, this coefficient is minus 1. This coefficient is minus 2. Where we started, we will end. Minus 5. Very simple. Here write it. Combination x1, x2, x3. The entire, the thing we are going to adopt, this the simplest method we can. We won't get any careless mistakes also. X1, you can see this. Yes, x1, x2, x3. How we are doing? X1 is written cross multiplication. Minus 2 into minus 2. Formula minus is there. Cross multiplication, we have to be very careful. This into this, minus, formula minus is there. Here multiplying minus 5 into 2, minus 10. But formula minus is there, it is becoming plus 10. Next, x2, 2 into minus 2, minus 4. Formula minus is there. Minus 1 into minus 2. These minus are our given problem minus. So minus 1 into minus 2, 2. Formula minus is there. So minus 2. Next, here you can see minus 2 into minus 5, yes, plus 10. Here this cross multiplication minus 2 plus 4. But formula minus is there. That is the reason here minus 4. Minus 2 into minus 5, 10. Minus of these 2. That is plus 4. It is becoming minus 4. So it is written. So x1 by this 12 we got it. This simplification we got it minus 6. We got it minus 6. x3 we got it. That is a 10 minus 4 we got it 6. So now we will take actually to consume our time the lowest form we can take it. 12 minus 6, 6 is there. The common is 6. So 2, that is a divided by 6 we are doing. This is 2 we got it. Minus 6 by 6 we got it. Minus 1. 6 by 6 we got it. 1. The arbitrary constant that we are taking as k. Arbitrary constant. The meaning is we can assign any various values, but still it remains unaffected by the changes in the value of the variable. So this k, the arbitrary constant, any, that is, you can see here now, x1 equal to this 2 into k, 2k, minus 1 into k, minus k, 1 into k, k. So this k is the arbitrary constant. We can assign any values, but we are taking simply k as 1. So capital X equal to x1, x2, x3 equal to 2k minus k, k. So 2 minus 1, 1. That is k, wherever the k we put 1. So it is becoming 2 minus 1, 1. Put k equal to 1. So when lambda equal to 8, that is the eigenvalue, when lambda equal to 8, we got this is the eigenvector. That is 2 minus 1, 1 is the eigenvector when it is, that is when lambda equal to 8, we got it. Next, eigenvector corresponding to the eigenvalue lambda equal to 2. We have to keep in our mind the 2 is repeated. So the a minus lambda I x equal to 0. This we have taken as it is, yes. Now lambda equal to 2. That is wherever lambda we are going to put 2. So 6 minus 2, 4. 3 minus 2, 1. 3 minus 2, yeah, 1 we got it. Remaining and all as it is written. Now, yes, it is, we can understand more. So 4, 1, 1. This values, these elements, we got it when lambda equal to 2 substituted in this place. So this is the matrix, we got it. Now we know it how to do the multiplication. So we are taking 4 minus 2 into 2. This is the equation, we got it. Second one we have taken, multiplying, we got it. Next 2 minus 1, 1. Multiplying, we got the third equation. So the 3 rows. solving these three equations, we have to get the value of x1, x2, x3. For that we are taking equation 1 and 2. It's not a strictly 1 and 2. We can take any two equations. Now 4x1 minus 2x, this is the first equation. Second equation, yes. This method, first we will take the middle minus 2. Second one we will write it. Next we will write where we started, we can end. We can check ourselves. Next what? So 1, next minus 1, next minus 2, plus 1. See here, where I started, we ended. Here also, we ended. Very simplest method. So this is x1, x2, x3. You can see this. So we can understand very clearly. Now x1 by cross multiplication. This we have to do cross. Minus of this cross. That's it. Minus 2 into minus 1, 2. Minus this 1 into 2, 2. We got it. Next, this multiplication. 2 into minus 2, minus 4. Minus, formula minus is there. Minus 1 into 4, minus 4. But formula 1 minus is there. So plus 4. Next, this. 4 into 1, 4. Formula minus is there. Here multiplying, we are getting plus 4. Formula minus is there. So 4 minus 4 equal to k. That is the arbitrary constant. So if you are seeing 2 minus 2, 0, 0, 0. So we have got it. x1, x2, x3, 0. We should not get 0 because we know it. Capital X is a non-zero vector. That is the definition of eigenvalue and eigenvector. So according to the definition of eigenvalue, Ax equal to lambda x, where, here x should come, x is not equal to 0. That is, x is a non-zero vector. It should not be a zero vector. Now, so we have to now declare the arbitrary constants. So x2, it is repeated. The eigenvalues are repeated. So we are going to declare two arbitrary constants. That is, x2 we are going to declare as k1. x3 we are going to declare as k2. Substituting in equation 1. That is, this equation we are going to substitute the values, that is x2 as k1, x3 as k2. So, this written as it is. Here substitution has taken place. That is x2 place k1 we substituted, x3 place we substituted, k2 we substituted. Now 4x1 equal to, this is a simplifications. The terms we push to the next, the right hand side. So minus 2k1 it is becoming plus 2k1 plus 2k2 it is becoming minus 2k2. So x1 equal to, so the 4 just it has become down. 2k1 minus 2k2 by 4. So x1 equal to k1 by 2 minus k2 by 2, we got it. So x2 equal to k1, x3 equal to k2. Two arbitrary constants we declared. With these arbitrary constants, we obtained x1 as k1 by 2 minus k2 by 2. So capital X equal to x1, x2, x3, that is k1 by 2, k1. So here we can see two vectors we have to get it because 2 is repeated. Our eigenvalue lambda equal to 2 is repeated. That is the reason this we are adopting. That is, here this is for k1, this is for k2. Here k1 by 2 we wrote it. Here compulsory we should write minus k2 by 2. This both adding only we will get it, this one. That is k1 by 2 minus k2 by 2. It's nothing but k1 by 2 minus k2 by 2. Next, x2 is k1. Here k1. Here k2, x2 is, the value is k1. So it is written. So here we have to write it 0. Then only k1 plus 0 equal to k1 we will be getting. Next, x3 equal to k2. So that means k2 place we wrote it, the second matrix. Here we have to put it 0. Then only 0 plus k2 we will be getting k2. So now in the first this matrix, k1 we are taking common out. So the balance here is 1 by 2. Here k1 is coming out, the balance is 1. Now 0 as it is. Here k2 we are taking common out. The balance is minus 1 by 2. The 0 is written. Here it is written k2 taking, it is coming out. Then the balance is what? K2 into 1. We know it. That is the reason it is written 1. We know it. K1 equal to 1, K2 equal to 1. We can take any value. We don't want to make our problems more complicated. So 1 which will save our time. So K1 equal to 1, K2 equal to 1 we have taken here. So now when lambda equal to 2, that is the eigenvalue, we got the eigenvectors, that is 1 by 2, 1, 0 minus 1 by 2, 0, 1. So these are the eigenvectors we got it when lambda equal to 2. So we can see it when lambda equal to 2, this eigenvector we got it. When lambda equal to 8, we got this eigenvector. So we solved this problem. So we got 2 eigenvalue for the 2 eigenvectors. Lambda equal to 8 for this. This is the eigenvector. We will do one more problem based on this. That is, find eigenvalues and eigenvector of the following matrix. Here the given matrix is A is given. Yes, so we know it. Lambda is the eigenvalue of our given matrix A. That is our given problem. Then capital X is the corresponding eigenvector for the eigenvalue lambda of the given matrix A. By the definition, A minus lambda I into X equal to 0. So A actually we put written, that is our given problem. The matrix is written, lambda is written as it is. We know it. This given matrix is a 3 by 3 matrix. That is the reason this I unit matrix also it is taken as 1, 1, 3 by 3 order we have taken. And a capital X is the eigenvector. We have taken x1, x2, x3 equal to 0, 0, 0. Now this written as it is. We are not doing anything. As it is, simply we wrote it minus. But here we are taking the lambda inside. That is lambda into 1, lambda, lambda into 1, the lambda into 1, lambda. So this is the matrix we got it. Here we are doing the subtraction. So if you are noticing here the principal diagonal, the lambda which lies. So there only the changes are going to come, remaining and all, because the 0, we know it, it is the additive identity in mathematics. So 2 minus 0, same only, it won't affect any value. Minus 3 minus 0, minus 3 only. So only we can concentrate the principal, that is the diagonal elements, that is minus 2 minus lambda, yes. 1 minus lambda, yes. Then 0 minus lambda minus lambda. So the characteristic equation of A is nothing but determinant A minus lambda I equal to 0. That is, this particular matrix, we are going to find the determinant. So that is what the symbol determinant. So this determinant to find either this row R1 way also we can do, otherwise C1 column way also we can, anyway we can do it. Here we are doing expanding by R1. That is, here this element is written, yes, which here the position this element is taken, then the complete row, complete column we will neglect. The balance one we will find the cross multiplication, that is this cross 1 minus lambda into minus lambda. Yes, fine, we wrote it. Then this cross multiplication minus 2 into minus 6 plus 12, but formula minus is there. So that is this into minus of this cross. So minus 12. Next. Oh. This position is the matrix to find the determinant positive. The sign is positive sign. Here the position sign is minus. That is the reason here minus is written. That 2 is written. Next, here this position is there. So if you are taking this position cross multiplication, the where it is there, that corresponding column row we have to neglect. We have to omit. The balance one only we have to do the cross multiplication. So 2 into minus lambda is fine. Minus 2 lambda. Minus 1 into minus 6. We know it plus 6. But how we got it here minus 6? Because we know it. The cross multiplication, this into this minus of this cross multiplication. That we have to be very careful, because a single mistake also, it is very difficult even ourselves to identify while writing in the exam, which will create a tension. So while doing the problem only, so better we can concentrate. Telling also we can do of nothing wrong in it. So this cross minus of this cross we are doing. Next, this position. This plus position, minus position, this is plus position. So as it is we wrote it. Next, here the element is there minus 3. So minus 3 is there. That particular row, particular column we will neglect it. Balance means here only. That is this one. Cross multiplication. So 2 into minus 2. Yeah, fine. Minus 4. Minus 1 into this one. But here it is written plus, because these two cross minus of this cross. That is the reason here plus is written, equal to 0. So it is written here as it is. Now we can see 2 minus lambda. This as it is we written. Here minus 2. And here minus 2 lambda. And minus 6. This also written as it is. Here minus 3. Here minus 4 plus 1. The simplification done here. That is minus 4 plus 1. The simplification is written minus 3. And next step. Here we did the multiplication. That is minus lambda we have taken inside. 1 into minus lambda minus lambda. Minus lambda into minus lambda plus lambda square minus 12. Fine. Next. Here minus 2 is there, minus 6 is there. Common we have taken minus 2 outside. Already minus 2 is there. Minus 2 into minus 2, it has become plus 4. Balance is lambda plus 3, we got it. Here minus 3 is there. Here common minus we have taken out. So minus 3 into minus 1, it has become plus 3. Balance we wrote it. That is lambda plus 3. So now this part as it is. Here this lambda square minus lambda minus 12. That is a simple actually factorization we did. That is a factorization, we know it. This if you are multiplying we have to get it. Minus 4 plus 3, it's nothing but minus. That is, this is a quadratic in terms of lambda. So minus lambda. The minus 4 into plus 3, minus 12. That is a factorization method we studied in lower classes. And for this as it is, this term also as it is written. That's fine. Now, if you are seeing one term is there, here one term is there, here one term is there. So now, all the three terms, lambda plus 3 is common. Yes, we have taken out. Here balance is minus 2 minus, fine, we wrote it. Here the balance is, here this lambda plus 3 common, here this minus 2 minus lambda, this lambda minus 4 we have taken. Here the balance is plus 4, here the balance is plus 3. It is written. Now, lambda plus 3 minus this as it is, here also as it is, only plus 4 plus 3, the change we brought it here, plus 7. So that is written. Now, lambda plus 3, these two we did multiplication, that is minus 2 into lambda, minus 2 lambda, minus 2 into minus 4 plus 8, minus lambda square, next this plus 4 lambda, this is plus 7. Yes, this as it is. Now, minus lambda square, minus 2 lambda plus 4 lambda. This part, it has become 2 lambda plus 8 plus 7, it has become plus 15. So, just actually lambda plus 3, we actually changed the sign, that is a lambda square minus 2 lambda minus 15 equal to 0. So, lambda plus 3, so if it is, so here it is lambda square minus 2 lambda minus 15 equal to 0. Here we did the factorization we did, that is lambda minus 5 into lambda plus 3 equal to 0. You can check it also. This is minus 15, minus 5 plus 3, it's becoming minus 12. That is a factorization method. Now, lambda plus 3 equal to 0, lambda equal to minus 3. Lambda minus 5 equal to 0, lambda equal to 5. Again, this one lambda plus 3 equal to 0, lambda equal to minus 3. If you are seeing the eigenvalues, lambda equal to minus 3, 5, minus 3. Minus 3 is repeated. So, the eigenvalue minus 3 is repeated at 1, 5 we got it. So, the repeated eigenvalues we have to find the eigenvectors. So, we got it minus 3, minus 3, 5. So, eigenvector corresponding to eigenvalue, first lambda equal to 5 we are finding. So, a minus lambda x equal to 0, this actually we know it, the non-zero solution x of the homogeneous system is the eigenvector, for the eigenvalue lambda of our given matrix A. That is our given problem. Now, this already we got it, this one. So, lambda equal to wherever lambda, we have to put it, lambda place 5. So, we got minus 2 minus lambda minus 7, 1 minus 5 we got it minus 4, minus lambda, so minus 5. So, you can see this rectangle to 1. So, minus 7, minus 4, minus 5, that we substituted the value of lambda equal to 5 in the places we got minus 7, minus 4 and minus 5. So, we can see this is the latest the value of the matrix we got it. So, we know it how to multiply, that is minus 7 into first row we will take minus 7 into x1, yes, minus 7x1, 2 into x2, yes, plus 2x2, minus 3 into x3, yes, minus 3x3. Similarly, the second row multiplied and we got it, then third row multiplied, we got it. Solving these equations solve, and we have to get the value of x1, x2 and x3. We are taking now equations 1 and 2. Yeah, equations this 1 and 2, it is written. Yeah, simple that method I told. So here the first step, plus 2, minus 3, minus 7. Where we started, we will be ending. Now with this also, minus 4, minus 6, 2, minus 4. Simple. x1, x2, x3. You can see this rectangle. Yeah. Now cross multiplication. Simple. x1 cross minus 12. Minus of cross. That we have to remember. So minus 4, minus 3, plus 12. So minus 12. Next, x2. This cross, minus 6. Here cross is plus 42. But minus of cross. So minus 42. Next, x3. This is plus 28. So here plus 4. Minus of this cross. Minus 4. Equal to k. We have to declare arbitrary constant. So this is the thing we got it. So x1, this is the value, minus 12, minus 12, minus 24, minus 6, minus 42, minus 48, 28 minus 4, 24, we got it. Lowest form we are taking, which will consume our time. That is, throughout 24 we have taken common and divided. So minus 1, minus 48 divided by 24, minus 2, 24 by 24 we got it. So now, so we declared here the arbitrary constant k. So x1 equal to minus 1 into k minus k. Minus 2 into k minus 2k. 1 into k, 1k. That's what x3 equal to k. So capital X is the eigenvector, x1, x2, x3. It's a 3 by 3 matrix. We know it, our given problem. So x1 minus k, x2 minus 2k, x3 is k. We are taking simple. We don't want to make our problem more complicated. That is the reason k can take any value. But we are taking k equal to 1. So minus 1, minus 2, 1. That is k plus we substituted 1. So when lambda equal to 5, we got the eigenvector minus 1, minus 2, 1. Yes, we know it. Actual eigenvalue, we got it. Lambda equal to 5 at minus 3, minus 3. That is minus 3 is repeated. That is only here our topic. Repeated eigenvalue, this how to find the eigenvector. A minus lambda I into x equal to 0. The matrix. Now, lambda place we have to substitute minus 3. Here, here, here. We have to put minus 3. Minus 2 minus of minus 3 plus 3. We have to be very careful. So, minus 2 plus 3, it is becoming 1. Next, 1 minus of minus 3. So, 1 plus 3. Next, minus of minus 3, it is becoming 3. You can see this part also. So now the matrix is written and this is the multiplication. We know it, the first matrix, row we will take 1 into x1, x1, 2 into x2, s2, x2, minus 3 into x3, minus x3. Similarly, second row multiplying we got it, third row multiplying also we got it. 3 equations we got it. Now, we have to solve this with the help of these equations. We have to find the value of the 3, x1, x2, x3, that is the eigenvector we have to find. For this, we are taking solving the equations 1 and 2. Any 2 equations we can take it. It's not strictly we have to take 1 and 2. So now, say 2 minus 3. Here this is 1, 2. Simple. Next, 4 minus 6, 2 plus, so you can see where we started, ended. We can recheck what were the steps while solving the problem, whether we are going in a right path or check, and we can move. Because if you commit any error to going back to check while in the exam writing, it is very difficult. So x1, x2, x3. So this animation part also. So x1, x2, x3. Very simple one. x1 cross, yes, 2 into minus 12, fine. 4 into minus 3, minus 12. But minus of minus 12, plus 12. Next, minus 6. Minus 3 into 2, minus 6. Minus of this value. So, minus 6 into 1, minus 6. But minus of minus 6, plus 6. Here, 1 into 4, 4. Minus of this, 2 into 2. So, 4 minus 4 equal to k. That is the arbitrary constant. So, you can see here. So, we got it actually, the values all 0, 0, 0. Completely x1 equal to x2 equal to x3 equal to 0. That means 0 vector we are getting. But according to our definition, eigenvector is a non-zero vector. So, it is not possible. So, we can declare the arbitrary constants. According to the definition, that's what written. That is, this is x, this is ax equal to lambda x, where the eigenvector is not a zero vector. It is a non-zero vector, but we got it completely zero vector. So, this is the equations. Take equation 1, that means this equation we are taking, and we are declaring it is repeated. So, two arbitrary constants we declared. There is x2 as k1, x3 as k2. Now, we are going to substitute this value of x2 and x3 in equation 1. That is, you can see here, this is the equation 1. The equation 1, x2 the value k1 and x3 the value k2 we are going to substitute. Yes, we substituted. So, x2, that is first, before that we are doing the simplification, that is the value what we wanted x1, that we kept it as left hand side. The remaining terms we brought it to the next right hand side. So, plus 2x2 it has become minus 2x2, minus 3x3 it has become plus x3. So, x1 minus 2k1 plus 3k2 we got it. So, k2 equal to, we got it x1, and k3 we got it k2. That is, these two we have taken. With this help, this we got it. Now, capital X equal to x1, x2, x3. Two eigenvectors, because it is repeated. Our eigenvalue minus 3 is repeated. The first one is for k1, second one is for k2. So, minus 2k1, this is 3k2. Both adding, we got it this one. Next, x2 has k1. So, that's what written. Here, why we have taken 0? k1 plus 0 only we will get it k1. Next, here, this is k1 place. 0 plus k2 only we will get it k2. So, now, in this matrix, k1 we have taken out. The balance is minus 2. Here the balance is 1, 0 as it is. Here also k2 we have taken out. Here 3 balance, 0, k2 here 1. So, put k1 equal to 1, k2 equal to 1. So, when lambda equal to minus 3, that is the eigenvalue, then the eigenvectors are minus 2, 1, 0, 3, 0, 1. So, now, when lambda equal to minus 3, we got these two eigenvectors, that is minus 2, 1, 0, 3, 0, 1. When lambda equal to 5 eigenvalue, we got it x equal to minus 1, minus 2, 1. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.